welcome back to another video. In this video, we are going to learn about a faster alternative to HashMap data structure. Now, if you have worked with data structures and algorithms in the past, or if you have solved any kind of question on platforms like LeetCode or HackerRank, you might be familiar with the HashMap data structure. But in case you haven't, then don't worry, because after watching this video, you won't even need to use the HashMap data structure anymore. Now, to understand it, we are going to work with a problem on the platform LeetCode. The name of the problem is valid anagram. First of all, let's see what we actually mean by the word anagram. So anagram is basically a word or phrase which is formed by rearranging the letters of a different word. For example, let's say we have a word astronomer. Now what I'll do is I'll rearrange the letters of this word exactly the same number of times to get another word which is moonstarer. In a more straightforward language, we could say that two words are anagrams of each other if they contains the exact same letters repeated the exact same number of times. So we had the word astronomer as our original word. Now if we extract each and every letter from this word and then write their respective counts, we get something like this. So the word A is repeated one number of times, E is repeated once, and so on so forth. Now if we do the same thing for the word moonstarer, we see that both of the words have the same letters repeated exactly the same number of times. So we could confidently say that both of these words are anagram of each other. Now first of all, let's try to solve this question using HashMap. So for those of you who have already worked with HashMap, can easily figure out how we could solve this question using HashMap. So what we are going to do is that first of all, we will compare the lengths of both the strings S1 and S2. So if the lengths of these strings do not match, then we could confidently say that they can be anagram of each other. Now in the next step, we are going to create two maps, map 1 and map 2, to store the number of occurrences of the letters in the string S1 and S2 respectively. So for the first loop, we store the number of occurrences of the letters in the string S1. Now in the second loop, we do the same thing for string S2. Now in the third loop, we are checking if both of these maps have the exact same entries or not. If they do not have the exact same entries, we will return false. Otherwise, we will return true. So now let's try to run this question. We could see that our solution runs successfully. Now let's submit this solution. So our solution works perfectly well, but notice the runtime here. We could see that it takes 15 milliseconds to run our question using a HashMap, which beats only 29% of the users. So I don't think it's much optimal. So what we are going to do instead is that we will use something known as a hash table. So a hash table is nothing but a simple array of size 26 because the English language has 26 alphabets. Now each index here represents a letter. Like for example, the letter A is represented by the index 0, B is represented by 1, and so on. And the value at each of these indexes is the number of times that letter has been repeated in the string. So this is a straightforward data structure that we could use to solve this problem more efficiently. Now, let's try to solve a question using this data structure. So first of all, what I'm going to do is create a simple array of int. Let's call it ARR1. Now this array will be of size 26 because as we discussed that the English language contains 26 alphabets. And I'm going to create another array known as array2 for storing the occurrences for string s2. Now, first of all, I'll iterate for string s1. So for every character in s1, now inside the loop, first of all, I will get the position of the respective character by using a simple trick like this. So what I'm basically doing here is that first of all, I'm getting the ASCII value of the current character and then subtracting it with the ASCII value of the letter A. So if our current character is A, then A minus A, we will get 0. And for B, we will get 1, and so on and so forth. So this is just an easy trick to get the actual position of the character in the array. Now, inside the array, I'll be incrementing the value at that position. Now, after the first loop is finished, array1 is going to look something like this. So for every letter that we have in the word astronomer, we will have some count. Like for example, the letter A has count 1, letter E has count 1, M has count 1, and so on and so forth. And all the other letters that are not included in the word astronomer will have count as 0. Now I'm going to repeat the same thing for string s2. And after the second loop is finished, the array2 is going to look exactly same as array1, because both of the words astronomer and moonstarer has exactly the same number of letters repeated the same number of times. Next, we will create another loop, and this time I'm just going to run it for 26 times, because as we know that the number of alphabets in English language is 26. Now here I will check if the occurrence of each letter in the both of the arrays is same or not. If it's not the same, then I'd simply return false. That means that both of the strings are not anagram of each other. But if all of the occurrences are same, then I will return true. Now this solves our problem. So let's try to run this. So our solution runs perfectly. Now let's try to submit this question. Now as you can see that the runtime now is just 3 milliseconds compared to 15 milliseconds that we were getting using HashMap. So the HashMap runs 5 times slower than this solution, which means that this is 5 times faster than HashMap. So instead of using HashMap, we could simply use an array to solve this kind of question. So whenever you feel the need of using HashMap working with strings, try to use a simple array instead of using a HashMap. Now you might be wondering that in this question, it's mentioned that all of the letters in the string will only consist of lowercase English letters. So we could take the size as 26. But what if it could contain any kind of character? Then in that case, instead of taking the size as 126, I would take 128, because the ASCII values goes maximum up to 128. Now instead of using this trick to get the actual position, we could simply take the ASCII value of the current character, and instead of running the loop for 26 times, now let's run it for 128 times, and this would work just as fine. See, it works just as fine. So next time, whenever you are doing a question based on string manipulation and you feel the need of using HashMap, then try to use a simple array instead. Thank you so much for watching the video. I hope you liked it. And if you found this video helpful, just give me a like and share this video with your friends. And to watch more such videos, subscribe to my YouTube channel Programming Ninja.